Good evening, everyone. I am K.S. Narayan. I welcome you all on behalf of the IIT Alumni Center, Bengaluru, for this 59th webinar. We have been conducting these webinars online since April 2020. It's really been a successful webinar, and you can find all the 58 webinars which we have had so far on our YouTube channel. And this typically happens live online on Saturdays, typically 5 in the evening, twice a month. And it's been spearheaded by Dr. Sushila Venkatraman of IITACB, who's there with us. So the topic for today's webinar is experiencing the business and talent transformation in an Industry 4.0 landscape. And this is going to be presented to you by Dr. Raunak Bhinge, who's the founder and CEO of Infinite Uptime. Infinite Uptime is one of the fastest growing predictive maintenance and plant reliability solution providers across the globe. Now, for over a decade, Raunak has been active in this field of smart manufacturing industry, Industry 4.0, innovation and applying these digital technologies for transforming manufacturing businesses. Raunak is a B.Tech and M.Tech from IIT Madras. He went on to do his PhD at University of California in Berkeley. Somewhere in between, he was also a founder of a very interesting organization called AV Pulse, dedicated to ornithology and bird conservation, where I think the app is around digitizing bird sound and identifying the birds. So I'm personally quite interested in knowing more about that at some other point. So Raunak has published and has got numerous patents. He's passionate about connected ecosystems, the advancements in digitalization and sustainable manufacturing. Apart from his key areas of business interest include industrial IoT platforms, industrial diagnostics, data science, predictive analytics, and asset maintenance. Moderating this discussion will be Samir. Dr. Samir is the managing director at Inventous India. He has been an early stage venture capitalist investor in India since 2001. Prior to co-founding Inventous in 2006, he led the India venture investing team for Acer Technology Ventures, where he made early stage investment in the technology space. Samir is an active member and board member of many important organizations, like the SIGN in IIT Bombay, the TIE Bangalore, and so on. He is an alumni of IIT Bombay and IIM Bangalore. So we look forward to a lively webinar, and I encourage the audience and participants to engage in the discussion via the Q&A box, and not the chat box. Okay, so with that, over to you, Dr. Raunak.
Thank you so much for the kind introduction. So do let me know once you can see my screen while I present and speak.
Yeah, we can see.
Okay, perfect. Okay, so good evening to one and all, and thanks for the warm welcome. I'll be talking very briefly on an interesting space which you all must have heard of before, Industry 4.0, which is what is called the fourth revolution in the entire industry, which is going on today, which is the digital revolution. We'll also talk about what this revolution is, how it's changing the industry, how it's changing the kind of work profiles and skill sets that are required in this changing industry. And then I'll tell you about what we are doing at Infinite Uptime. We're a young company, about 5 years old, and what we are doing with various different digital technologies in the space of industrial automation. So that's how we'll go about this session. So just to give you an idea about what is this industry 4.0, right? There have been multiple revolutions that have happened in the space of industries, right? Um, the first revolution happened in the 18th century, which was called the mechanization, Industry 1.0. Then we had electrification, right? Which enabled mass production. So we had a lot of things like mass production of vehicles, which actually started, right? And then in Industry 3.0, we had automation. Automation was, industrial automation, which was, getting different machines to talk to each other. We had programmable logic control, where you can equip machines to do different things. You can have the same machine do 15 different things, which was not the case earlier. And also a lot of numeric control. So a lot of numeric control came in, robotic arms came in. So this was, from the 1970s onwards. Industry 4.0 actually brings in the entire digital space to the industry, right? So it is the convergence of assets, which is your physical assets, could be machines, could be robots, could be equipment, could be any different asset, right? And the entire digital space, right? So it's basically having a replica of the entire set of assets in the digital space, talking to each other, communicating to each other, sharing information, using this information from multiple assets to do better for the next asset that gets connected, and so on and so forth. It's called cyber physical systems. So cyber physical system is nothing but a system which is a combination of both physical as well as cyber, right? And it's the Internet of Things era at the moment, and the IoT has enabled connectivity and digitization of assets towards the digital space to enable all of this. So that is where Industry 4.0 is at the moment. We are in this era of the revolution of the industry, where digitization is happening across industries. And in the next, I would say, decade or so, it is a matter of time before most industries move into this Industry 4.0 era and digitize completely end to end. So, what does that mean in terms of talent development and skills? What we are seeing a lot is something on the top right: change management, right? Every time you have a revolution that comes or a transformation that comes in, one of the most important things that has to transform is the people itself, right? You can get new technology, new systems, new digital fronts, but at the end of the day, people have to run the business and the company. So change management has always been the biggest improvement that is required in the industries when you're adopting a change. Currently, most of the organizations are going through change management. A lot of them are having separate digital verticals. If you look at a lot of large manufacturers today, right? 10 years back, you wouldn't expect, a steel producer or a cement producer or a, mining company to have a digital head or a chief digital officer or a head of Industry 4.0 or a head of digital transformation. But today that's happening, right? A lot of these companies have leaders who are ensuring this change management and ensuring this adoption of digital technology to move towards Industry 4.0. So change management is happening as we speak. It is not an easy process. It takes time. These are all large organizations, large enterprises that we're talking about. But change management is happening. I know at least 2 large cement organizations in India itself, which have their own AI or um, data science or data analytics team, right? Something you wouldn't expect again 10 years back. And the same is being replicated in different places. You actually have digital profiles of people being hired in steel plants. You have digital profiles being hired in mining industries. We are seeing a lot of people with computer science background being hired into these industries, which was not the case again, several years back. So use of data is going to become extremely critical in the industrial space. And that has been enabled by this whole digital transformation. Now, because assets are becoming more and more connected, right? Workforce is also becoming more and more connected. And labor, which is on factory floors in industries, are also becoming more and more connected. So a lot of data is actually becoming easily available in industries. So earlier, a lot of data analytics and data science was typically used more in the BFSI space or fraud detection and more on the e-commerce side and the B2C side. And the B2B segment, right? Because you have so much data now available, on at your fingertips in all these plants, factories, you know exactly which machine, what is it doing, how is it performing, what role is it actually functioning, is it good enough to perform that role, does it have a problem that needs to be fixed, prioritization, optimization, route management, inventory management. A lot of problems, typically industrial engineering and operation research related problems can also be solved with big data. And micro problems right up to robotic, motion optimization to macro problems like reducing the greenhouse gas emissions of say a steel plant, right? The variety of problems that can be solved using data science. So a lot of talent around data science, data management, data analytics is being sought after in the industrial space, which was not the case earlier. So this is a big transformation that is happening in the workforce. Um, and having an understanding of IoT, having an understanding of connected assets, digital assets, um, and having people who understand this along with just the metallurgy process, let's say in a mining industry, is being looked at more positively. So I think this is something that all of us, all students will have to look at, is whichever field we might be, whether it's mining or mechanical or whichever. I think data is the future, right? And the more we can do with data, the more it's going to be useful for these organizations going forward. So that's what's happening overall in the in the industry, and the change management and the workforce transformation that's happening is exactly in the same lines. So I'll just talk a little bit about, now given the context of Industry 4.0 and, all of this digital transformation, Infinite Uptime, what exactly do we do and how do we help these industries, right? We will talk about that. So if you think of a steel plant or a cement plant or, any of the typical asset intensive heavy industries, right? The biggest problem that most of these face is unavailability of equipment, equipment failing or going down just when you want to actually ship a production batch, which impacts the entire top line and bottom line, right? These failures are random in nature because they are on fairly dynamic equipment like very large motors, right? Very large fans, very large gearboxes. um, and these are the kind of assets which actually run an entire plant. So you can't run a plant without motion, right? So motion is generated from motors, they are generated from pumps, they're generated from gearboxes, right, to transfer motion. And these are all very heavy mechanical assets, right? They're typically seen as mechanical assets. They're basically machines which do a lot of hard work and typically analog in nature, right? So this is where there are a lot of problems today in the industry, where these equipment fail, and they have a lot of downtime and a lot of loss associated to these downtimes. Of course, there are a lot of other side issues that come along with these failures. There are impacts to health and safety. If you have a very large exhaust fan in a steel plant go down, there's a high chance of it hitting somebody, right? And you actually have a health and safety issue. Huge amount of pollution that can happen through something like this, right? Imagine a phosphorus acid plant or a sulfuric acid plant, having a major breakage, or a breakage in an acid cylinder, right, or a pump which is running a very critical acid. The kind of impact it can have on the overall environment, on the people as well. So a lot of other issues that also are related to just the fact that equipment are not, very predictable, right, today. Not that anybody is doing anything wrong or any practice is wrong. It's just that they're not very predictable, because of which these accidents do occur, right? And they occur across industries. It has nothing to do with one industry versus another. So that is the main challenge, that this industry is in, and there's a lot of companies, a lot of technologies working, to solve this problem. It's quite a big problem in the industry. So just to give you an idea as to what we do at Infinite Uptime, We are a fairly young company. We started about 5 years back. So we were born in the digital space, data space. Industry 4 was already a big trend. So we were lucky to, to kind of pick up directly and start off directly, using cloud-based technologies, using digital native technologies, right? We didn't have any legacy equipment, legacy software or legacy equipment to work with. So basically, we utilize the digital technologies, the concepts of industrial IoT, and we actually worked on digitizing these fairly heavy assets, mechanical assets, right, in these industries. These large gearboxes, right, large motors, large, exhaust fans, IDFD fans, pumps. Started digitizing these, very quickly, right? So we built our own IoT devices. We just put these onto these rotating assets and start, getting them to talk, right? Once you have, today we have, 20,000 plus of these, assets talking, for example, right? And, that will keep growing. And just like us, there are companies in the US and, other parts of the world who are also working in a similar space. So as more and more assets start communicating, right? The important thing is there is a huge number of assets out there. There are more than 10 billion critical of these assets in industries all across the world. So it's important for a lot of companies to come together and help these industries digitize all these assets. Once these assets are digitized and they're actually talking, right? You actually have the right amount of good quality data and information about what these assets are doing, how they're performing, what are they feeling, do they have an issue? If you can predict a failure, right? A typical, let's say a bearing fault, or you could predict that something's going to fail, and you can take action before it fails. It has a huge impact, on a user. So you look at this typical application, and cement industries are adopting this globally, where they're actually digitizing all their assets, from conveyors to kilns to silos, to elevators, exhaust fans, various different types of applications. Digitizing all of these, right, and ensuring that each and every asset is actually sending out information about exactly what it's doing, what it's performing, what its health is like, what exactly is happening, right? Once this information is available, then you have all the data science experts, right, who come in and actually use this data to build something useful. In our case, we are in the business of predictive maintenance, so our job is to predict faults before they happen. So we have our analytics engine and our team which delivers accurate insights on these equipment. So for example, you can tell a customer or tell a user that, hey, look, your gearbox is about to fail in the next 30 days. Right? If you take a shutdown in 20 days, when your batch gets over, or when your cement production batch gets over, you can actually save this from failing during the next batch. And that's an extremely important piece of information for them to know. And apart from saying something's going to fail, the next best thing is what exactly is going to fail. Is it the bearing that's going to fail, and what do they need to do? Do they need to replace the bearing? Do they need to do lubrication? Do they need to do additional, do they need to do an oil inspection in addition to what they've already been doing? Or do they need to move to a standby, right? So there's various different types of recommendation that can be given. So typically identifying a fault, pinpointing and diagnosing exactly what the problem is, and then recommending a corrective action is actually the business of predictive maintenance, right? So you predict a fault and you tell exactly what needs to be done when and how much time they have, right? And that is measured with false positive, false negative, which is typically your metrics to define accuracy of predictions. So similar kind of methodologies are also used, in optimization techniques, in productivity enhancement techniques, in quality optimization, right, of these plants. I know at least a couple of cement plants who are actually using IoT, digitization, and all of these similar technologies for improving their yield, right? So from the same input, can I get more output, which can be sold to the market, right? Which is improving yield, also improving quality, right? So there are a lot of quality issues that come in certain batches. What are those process parameters, and what is that batch of process parameters that gives the best quality? That's called the golden batch, the golden yield. And that golden batch is usually the sought after batch in most process industries. So there's applications around that for digital technologies. So while what I'm presenting is one application, there are many more parallel to this which happen in the same industries. So this is basically a gist of what we do, right? Help digitize assets, collect the right information, predict faults, find exactly what's going wrong, pinpoint what can happen, what is going to go wrong, what needs to be done, and by how much time. And this information to a maintenance engineer or a person in the plant is extremely useful to save a major breakdown, which could have resulted in huge losses or potential impact to human health and safety. And basically, what we are driving towards is something called the optimum point in maintenance strategies. So typically in the industrial space, you have what is called preventive maintenance and reactive maintenance. Reactive maintenance is when you just wait for something to break down. Once it breaks, you go and fix it. It's reactive, called breakdown maintenance. There's preventive maintenance where you just stop the plant every 10 days and just replace all the bearings or fix all the check everything every 10 days, every 20 days, right? And that is over maintenance, right? Yeah, you won't have a single breakdown, but you're also not optimized. You're not using your plant efficiently. So there's always a swing between preventive and reactive. Every time there are breakdowns, you kind of over maintain. And every time you're over maintaining and you're seeing you're not getting the kind of throughput you want, you kind of relax that and you start having breakdowns. So there is an optimum in between, which is what predictive maintenance enables. And this is something which only with digital technology it's possible, is where you're continuously monitoring and streaming information from every single asset, knowing exactly what's going to happen when, giving that right piece of information at the right time, so that maintenance or action is taken only when required, so that you don't have breakdowns and you're having the maximum amount of production. So you're not over stopping or over maintaining either. And that's kind of the sweet spot that everybody looks for in most applications, so most production applications. So Infinite Uptime, just to give you an idea, we, have, been around for about 5 years now. We've documented savings over 3,600 hours for customers globally. We're monitoring over 255 different process plants, 16,500 different locations, different equipment. We're saving more than an hour of production downtime today, every hour of the day. So every hour of the day, we're saving more than an hour in production losses somewhere in our customers. And we've grown quite significantly over the last couple of years when we actually started working with customers in the industry. Today, we're working with about 220 plus top companies. And what a user actually gets when they work with us is pretty much on the lines of what we just discussed in terms of predictive maintenance, right? Digitizing machines and being able to get exact information on what needs to be done when, what action needs to be taken. We create a lot of these AI-driven metrics like health scores or efficiency indexes or before after maintenance effectiveness, right? I mean, if you've taken an action based on a health score being reduced, how effective have you been once you've taken that action, and have you actually recovered that machine completely to a healthy state, or has it been a haphazard kind of a action that was taken? So because you have digital technologies, you can actually be able to pinpoint all of these. For example, you say there's a bearing fault and the person takes action, but the bearing fault doesn't actually get resolved. You can actually immediately highlight that, but that's something that was not possible earlier. And basically, manufacturing is getting transformed. You have smart machines which are coming up. So while we are helping with all the existing plants and existing machines, out there, every new machine that's being produced, that's being created, is getting inbuilt with the ability to talk. Right? They're getting inbuilt with the ability to speak, to sense, to understand what's happening internally within them, and they are getting more and more ready to connect, so to say. So as new plants get built, right? Let's say there's a new cement plant being set up, a new steel plant being set up, and they've gone through this process in their existing plants. The new plant will, by default, be inbuilt with this kind of technology. It will be capable, the machines will be capable of figuring out what's going wrong. They'll be able to help optimize what action needs to be taken when. For example, there are, I've seen one application where a customer is able to predict a fault of lack of lubrication in a bearing. They're able to trigger a lubrication system. The lubrication system is auto lubricating the system, the bearing, with the right amount of lubrication to ensure, and it's also ensuring that there is no over lubrication. All this in real time is happening in some of the bearings of some critical applications. So these are just examples of what's new, what's coming in the field. A lot of video analytics is also coming in as manufacturing is transforming. So image processing and video analytics to look at quality, coming out of any production line. Video analytics to detect whether people are wearing safety equipment or not is a big use case which is being used, and a couple of companies working on that. And also video analytics to see whether equipment are running fine. We have really high speed cameras being used to predict any variations or any changes. Let's say you have a motor which is vibrating. If it starts vibrating or your pixels start moving, you can actually capture that in real time as well. There are a lot of different applications with big data that are coming in. That is being driven. So finally, just to share with you what we are working on at Infinite Uptime is working on taking all the maintenance technologies, right, that are out there, right? So right from vibration analysis to oil analysis to various different technologies, digitizing all of those technologies with all these assets through a common solution to our customers, where we are helping them take corrective actions and save downtime. So that's fundamentally what we do. We are playing our part in this entire industry 4.0 or digital transformation of industries as a whole, and we are assisting our users and the industries and the plants to be that much more efficient, so that they can get more output from the same plant that they have been running for so many years. And none of these plants are getting any younger; they're all getting older like us. So the more they can get out of this for the rest of the life of that plant is only going to help and improve the plant yield, the plant productivity, and use less resources, which is good for the overall environment, right? So that's all from my side, Samir. You can take it over.
Sure. Thanks, Raunak. So we'll pause for a small question answer interlude right now. I don't see any questions in the chat, in the question and answer box. So maybe I'll just go with my question. Raunak, first of all, thanks for giving us a very good overview of what Industry 4.0 is and what Infinite Uptime is doing in this space. But one question that keeps haunting me all the time is, especially when we talk of talent and the reskilling and talent transformation for Industry 4.0, what happens to the existing workforce in industrial plants? Do they become obsolete? Can they be reskilled? Is the reskilling required for them manageable, or is it beyond their grasp? Would love to hear your thoughts on that.
A bit of both, Samir. So, in some cases there is, and part of this change management, and this transformation at workforce, the reason it takes a decade or more and not 1 year is exactly this, right? I mean, you can't bring in new people and throw out existing people immediately, right? Every organization allows its own team to kind of skill themselves, grow to the next level, adopt these technologies, get value out of this, and then upskill in their career. So that is what happens as part of change management and digital and organizational transformation, which is what is happening. Yes, in some cases it is not completely possible. You can't expect a certain workforce to actually be digitally enabled and start doing all of these things from day one. So it is a transition that takes place. It happens over a period of time. So while the number of lower skilled roles will reduce, the number of skilled roles will increase. You'll need more data scientists, you'll need more data analysts, you'll need more data analytics enabled employees in all of these industries, to help on all of these fronts. There's a big shortage of that right now.
Got it. So the other thing that keeps running in my mind is, and you mentioned this, that digital profiles are being hired in companies, in industries like cement and mining and so on. And you've graduated from IIT Madras 10 years ago. So the question is pertinent to you as well. Would digitally savvy people be, or in your experience, are they willing to join these industries like mining, cement, and so on? Or would they want to go to Wipro, Infosys, or whatever it is? Or join Infinite Uptime, for example?
So, I mean, there are, if you think about it, if you look at the metal, you look at steel, for example, right? Steel typically, you're looking for digitally savvy profiles, but you're also looking at people who understand process. So, people who understand the steel process, understand steel melting or cold rolling or annealing and blast furnaces and all of that stuff, right? So it's not just digital people, right? You just don't have a bunch of coders, a bunch of people who know how to do digital, data analytics. To do that, you need to understand the process to apply it. So it's application of data science in metallurgy, it's application of data science in cement processes, application of data science in all of these individual things. So application of data science is what is required, not just the data science. So it requires the information. So a metallurgy student who takes a bunch of courses, studies data science along with that, is a perfect fit for an organization like this. And they would see typically working with an industry like this, like let's say a steel industry, gives you that closeness to that process, right? Infinite uptime, we're good on assets and predictive maintenance, but we're not deep into the process, right? So, for a metallurgist, right, being close to the process is extremely important. And that's where, I see this, and it is happening. I mean, I'm seeing a lot of people from IITs, NITs joining these steel organizations, cement organizations, even FMCG companies, paper industries, in their digital teams, because they understand process as well as data science.
Got it. Thanks. So, I think we could continue with your presentation, and in the course of that, if more questions come along, at the end, we'll take your questions. So why don't you continue with the rest of your session? I do have a few questions, but I'll ask them in part 2.
Understood. So that's primarily what I had planned for today, Samir. So you can ask me the rest of your questions right now. That would be perfect.
Okay. So, meanwhile, also for the participants, if you have questions, put them in the Q&A box, and I'm sure we can put them to Raunak. But my question, Raunak, was, I keep hearing, and I'm a layman, so you have to pardon my ignorance over here on this issue. I keep hearing that Industry 4.0 is meaningless without 5G, but we already have Industry 4 here. So can you just talk about 5G, and first of all, whether this is a relevant point, and if so, what is 5G going to do to Industry 4.0?
Now, see, we could speak and access internet even when we had 2G. 4G only made it faster and much easier and much quicker and much more at scale and stuff like that, right? The same thing, right? I mean, we currently are digitizing assets with 2G. We're not even using 4G in some cases, right? Because they're so remote and far off that they don't have even 4G, forget 5G. So, for the immediate requirement of being able to collect the right information to do the right analysis and get the right outcome, yes, it's being done today. It doesn't require 5G. 5G will enable you to collect data super fast. You don't have to optimize on the amount of data you're collecting. You don't have to optimize on doing more stuff on the edge and less on the cloud and stuff like that, right? Today, you do a lot of that optimization. You'll do a lot of optimization of, okay, when should I send the data to the cloud? Because I have only limited bandwidth, right? That will change. What it will really impact is stuff like video analytics, right? Where you're doing video processing, image processing in real time. That's where 5G has a huge impetus. In basic IoT, I think it's just about scaling it up and making it available at mass.
Got it. So thanks for that. And one more question I had is, you talked of, and this is something that Infinite Uptime, you said, focuses on predictive maintenance. And you talked of accuracy there, and I saw 100% accuracy there. So is it that we have reached those levels of giving 100% accuracy on our predictions, or is it 100% accuracy for some subset?
Some subset. There is no 100% global.
That's what I thought.
Because
So
it's not
what would
relevant.
the accuracy level typically be?
Typically, it varies. It's from 92% to 96% is typically what we see. Um, so this includes both FP and FP, so false positives and false negative. False positive is you predict something, it's not found. False negative, you don't predict and fails. Right?
Right.
So typically, you're tilting your prediction algorithms more towards the false positive side because it's okay to have a few false positives, but it's really not okay to have a false negative where there's a large breakdown.
Right. Right. Got it. Thanks, Raunak, for that. There are a couple of questions that have come in the Q&A box. So let me just go one by one. This is by Mr. Chandrasekhar. What is the scenario of Industry 4 in the textile sector? So his question is specifically for the textile sector.
So I have very limited knowledge around the textile industry, to be honest. We have studied a little bit in the textile industry. Or textile machines that are used are typically very advanced. Typically comes from either Kirloskar, Toyota Kirloskar, or equivalent, right? Very high speed machines, very high end machines, clean room environment and atmosphere, not a typical heavy industry. So the while cost of downtime in textile industry is high, the occurrence of these failures is quite low from my initial assessment of this space. And that is one of the reasons why we didn't spend a lot of time in the textile industry. We focus more on the heavy industry where the occurrence of failures is more and cost of downtime is also high. So that is that is basically what I am. But again, I'm not the right or the best person to talk about the textile industry.
Got it. And there's a question from Siddharth Das, and I guess you know him, right? He probably is the investor in your company. But so Pune appears to be the hub of industrial IoT. And his question is, how has the ecosystem evolved over time in the evolution of technologies and customer pull? So I think this question is evolution of technologies and how has demand changed over time? And do you agree with him that Pune is the hub of industrial IoT? Comment on that also.
Pune is definitely one of the earlier set of industrial IoTs, right? Companies are all in Pune. Today, a lot of industrial IoT companies in Bangalore, in Delhi as well, and doing quite interesting work. But yeah, the initial crop of industrial IoT companies were started in Pune. Pune has that mix of IT, as well as manufacturing very close to the city. Right? So a lot of, especially automotive manufacturing, very close to the city. So a lot of IoT related to automotive industry, you will find more in Pune as compared to other areas.
Okay. And second part was the evolution over time of both technologies and customer pull.
Technology, of course, has evolved a lot. I mean, a lot of IT industry in Pune, right? So a lot of people have been skilling themselves in the IoT space and in industrial IoT as well. There are a lot of people who build backgrounds and careers in that industrial IoT segment, which is a very specific, focus area for them. And that is happening across the space. So definitely being an industrial IoT hub or industrial IoT being a space, a lot of people are trying to build profiles and careers in that, and adding value to these companies. In terms of customer pull is directly proportional to the value proposition and the value creation by the companies themselves, right? So adoption has increased over the last 1 year. So I would say 2019, 2020 were those very early stages for industrial IoT. And 2021 was really the kickoff period, I would say, for industrial IoT in the country.
Got it. And so there's one more follow-up question from Siddharth about the global slowdown. Has it had, he says, perhaps it has had some impact on the industry, and how do you see the future? So number one, has it had impact? What impact the global slowdown? And then how do you see the future?
So core industry hasn't had a major impact. So core industry, talk about power industry, talk about steel, cement. Yes, prices have reduced in the market, aluminum price and all of that. But I think they are all running at full capacity as we speak. In fact, a lot of them are expanding. Right, a lot of the cement groups, a lot of the steel groups are expanding. There's heavy investment in new plants, new expansions. Right. Um, in fact, most of the steel groups in India are doubling their capacities over the next 3 years. So while slowdown is probably, you can talk about late 2022, early 2023 period, most of these core industries, they'll typically look at 5-year winners. They look at much larger time ranges, and they're all quite bullish over the long run. So there is no slowdown from that front as such, and they're all investing in digital technologies. They're all going into this whole industry 4.0 with full speed, and they're also expanding at full speed. So core industries are definitely not heavily impacted. What I more impacted are tertiary industries.
And how do you see the future?
I think very similar, because we learn from our customers. So the way the customers are looking at, they're quite bullish over the 5-year period. They're saying that this is a bit of a bump for, I would say 3 to 4 quarters, and that we're looking at right now.
Got it. Thanks for those answers. There's one more question that has come, Raunak. Specifically for reskilling or upskilling the existing workforce, can you share some specific action points on what needs to be done?
So, for example, digital savviness, first of all, for example, in people who work in these plants, right? Typically, I'm talking about more of the workforce, right? Not the labor, but the first level of workforce, right? Is an important aspect which is missing. They spend 80-90% of their time on the floor, shop floor, fixing issues or going about doing a bunch of stuff, right? But when you look at the same people, how do they convert from 80% on the shop floor to about 50% on the floor and 50% doing actual analysis and value creation, right? And taking corrective action or taking actions at the right time, whatever action, maybe a production related action, maybe a corrective action for a maintenance related activity, whatever it might be. So I think that is one of the areas. And the second one is, the ability to, use programming and use this big data, right? Run it through an AWS platform and actually create some value for the organization. That is something that they're all looking for at the moment. This is something that will really help these organizations.
And the existing workforce could be skilled in these areas, is what
Can be skilled, but if they are not, they will definitely hire from us. And they are hiring. They're doing both. It's a combination, because the skilling happens over a long period of time.
Got it. But I think the question was also more from a concern that are the existing workforce just going to get knocked out, or there is a potential to reskill?
There is a potential. Like I said, see, for example, I won't take names, but one of our steel customers, they're doubling capacity. What they're doing in that doubling capacity, they're like, hey, look, let's use the same number of people to do double the work and enable them with a few hires in the digital side who can enable them to do double the work. So the way they're thinking is different, because we are in an expansion phase, right? At least India as a industry is looking quite positive, right? We are not slowing down expansions, and all new plants are being built, expansions are happening. So that is the way people are thinking. So it's not about people being released; it's about same people doing double work, and a few digital core team kind of enabling them with technologies and digital tools to be able to do that at the same efficiency and quality.
Got it. Thanks for that. So one more question has come in the question box. What has been your experience in finding or sourcing sensors required for the systems in India?
Yeah, so chips and sensors, right, are not made in India, and that is something. I mean, the whole electronics segment is something that has been lacking in India for a while. But I think with the new fabs which have been coming up, and I'm seeing a lot of news about India taking a very strong direction and the right direction, right, in setting up the electronics ecosystem and the supply chain in India itself. I think a lot of this will get resolved over a longer period of time. But in the short period of time, for any IoT company, I think fundamentally the source, the fundamental data source does come from various different types of sensors, which are all electronics, mostly electronics in nature, which does have a supply chain that extends outside India. And that's something.
And is that a complex supply chain, or are you able to get supplies, or are customers able to get those supplies?
Supplies are possible. There are a lot of delays. There are fluctuations in pricing, but it happens. But supply chains work. I think and it's the same with the auto industry, with the electronics like your smartphones, your tablets, your laptops. I mean, it's all the same story across. So we're all. I mean, the supply chain is there. There's no issue in the supply chain. There are variations. There are delays. Some price fluctuations, and that will be solved once India becomes more self-reliant on all of the electronics front.
Got it. So the next question is, and this is from Professor Mishra. He wants to know more about your company. So Raunak, I think you had some slides. You want to just quickly put up some slides. How does it help the industry go forward? He wants you to tell more about Infinite Uptime and how does it help the industry go forward.
Understood. So let me just explain. I think slides won't give you the best.
You can go ahead and explain. Yeah.
See, fundamentally, in heavy industry, right, process industry, heavy industry, which is the core of most of the economies of large nations, whether it's oil and gas, whether it's cement, whether it's steel, it's metals, aluminium, mining, any of these, 80% of all energy, right, most of the energy is consumed by rotating assets. So you have either a motor or you have a turbine or you have a large fan or a pump or something or the other, right? A conveyor, something like that. 80% of the energy is consumed by the rotating assets. And 80% of the impact of breakdowns, right, or failures or problems are from these rotating assets. They are dynamic. Anything that moves, which rotates, it's continuously moving, it has a wear and tear process, right? Deterioration that keeps happening, which is random. That is not, I mean, while in theory we talk about all the nice curves and diagrams and distributions, in reality, because the processes are not stable, they're not 100% the same day in and day out. There are variations in the inputs, there are variations in the process. So the deterioration is not predictable. It is not something that you can say that, hey, I don't need to look at this for the next 60 days. No, it could break tomorrow also. And we've seen that happen in a lot of industries. So what happened today cannot define what might happen tomorrow. And that is the state of the equipment in these industries, and they are 80% of them, right? So there, the impact of predictive maintenance is very high because you can take that organization from completely heavily reliant on manpower, where you have expert people walking around in the plant, which is first of all dangerous, going to these large rotating assets, trying to collect information from a handheld instrument or something like that, to try and give an educated guess of what might happen, and are actually bringing structure to that whole process. You're digitizing that whole process. You're digitizing the assets. You're taking that experience into a digital platform, into a system, where that experience is no longer constricted to one or two people, but actually everybody has access to that experience and that intelligence about what's happening in every equipment. So that is what Infinite Uptime is doing. And fundamentally, it is saving potential breakdowns. So let's say there were 300 hours lost in a cement plant last year. We bring that down to, let's say, 100 hours lost. This year, we take that to 50 hours lost the next year, and so on and so forth. And that additional availability that we bring to that plant, right, is additional throughput for that plant, is additional usage of raw materials, of power, of whatever. So one is it improves the overall yield and the productivity efficiency. It saves potential harmful damages to material and people, right? I mean, people have lost lives every year in the last so many years in these kind of industries due to these breakdowns, right? You have fans breaking and hitting a person or something like that. So this kind of, you wouldn't say 100% eliminates, but significantly eliminates the probability of all of these from happening. And also saves a lot of energy in the process. So you have a good impact. I mean, all the companies that we're working with today have carbon goals or emission goals by a certain period of time, 2030, 2050, 2040. Different industries have their different goals already set. So this kind of helps them move in that direction. And see, rotating assets are the fundamental. 80% of a plant is that. So if you solve that for them, I think it has a huge impact overall across the organization.
So if I were just to stretch your answer a bit, Raunak, I think what you said is by doing the things that you do for your customers, you not only increase their productivity, but it has an impact on overall GDP. If my plant is producing for more number of days in a year, then I'm contributing to the GDP of this country and so on and so forth. So overall, not just productivity of my own organization, but contributes to a greater good as well.
Yeah.
So thanks for that answer. And one more question has come, Raunak. I'll read out the question now. So you said that digitally savvy people are being hired in cement, mining, and so on. The question is, what is different about this new crop of people? What needs to change in the companies to retain this new crop of people and keep them happy, engaged, and so on? What sort of employee engagement initiatives are required? And also specifically, what does Infinite Uptime do to keep its employees happy and engaged and so on, or to help your customers?
Sure. So I think one thing that the new generation, a new set of students or people who are joining the workforce is their curiosity and inquisitiveness is very high, and their need or their hunger to solve more problems is very high. So they don't like to stagnate in the sense that solving the same problem every day versus solving newer problems and having more challenges is something that is important. In a growing company like Infinite Uptime, it's actually easy because we have hazard problems every day, and there are we have few more problems than people who can solve them, which is okay. I mean, because the startup is a growing company, you'll always have those growth challenges. But in larger organizations, that becomes a bit of a challenge, where you have to actually move the same team. So what I have seen is a lot of companies, they have a digital team, a core digital team. They don't have a digital team for specific problems. They have a core digital team. Let's say a cement plant, a cement industry, right? Let's say it has 30 plants. They'll have one core digital team which will be the digital team to solve the problems for those 30 plants. Now each plant will have its own problem. Some plant will have conveyor breakdown problems, some plant will have kiln problems, some plant will have some cooling tower problems, right? There could be different problems with different plants. So that is that continuous set of new problems that are being thrown at this data science team, and they have to come up with solutions using data, using digital, to solve those problems in a cost-effective manner and deliver ROI for the business. So they are in some sense the IoT startup within that industry, right? Which is also an exciting place to be today, because you're close to the action. There are a lot of people today want to be close to the action. They don't want. I mean, I think that era, there was that, I would say, 5-year set of people who came in who wanted to be more working from desks. I think I can see that changing now, and people want to be more. We just hired someone from IIT Kharagpur, I think, recently, and the guy wanted to be on the plant. He didn't want to sit remotely and see what's happening. It's like, no, I want to see the machine. I want to understand what's happening. I can't sit here and solve the problem. So we're seeing a lot of that, and that's a good sign. I think that's really good. People should be solving problems at the problem, not at their desk.
Absolutely. So you're seeing more hands-on nature from the employees who are coming on, and which is very good.
Yes.
So let's take Ashok Kamat's question now, and specifically, I'll read it out. Have you done any work in looking for potential cracks, either in the machines or in finished products? And how complex would such processes or systems be?
This is very hard. Crack detection is very hard. So we don't specifically or directly do this. Sometimes indirectly we do help customers find cracks in the bearing or something like that. But we typically don't say that we can help find cracks, because that's a very complex problem. Crack propagation is very hard to detect using real time. At least the technology we use is more vibration focused, right? But I think something more from strain gauges in real time can actually help solve the problem. It's just that I don't think we've tried to look for a solution around those lines. We've not been able to find a cost effective and easy to deploy, easy to scale solution with strain gauges which can be deployed. You have to stick it, and once it's stuck, it has to be in a very specific way. And it works great as an apparatus, but it hasn't worked great as a product which can be scaled in the industry, which can have a 10-year life, and so on and so forth. I think that's where structural health monitoring has exactly this problem. Rather than machines that we work with, I think structures will have this more relevant, like bridges and large steel structures. A lot of new buildings are now built on steel structures rather than the traditional ones. So the steel structures have this challenge of crack propagation. So that is something that will be very important there.
So clearly what you're saying is there is an opportunity for a new breed of startups to sort of come in and tackle the cracks or in finished products and machines and so on. How they do it, the more complex it is, the more the opportunity, I guess, for that startup.
Yeah. I mean, if Ashok specifically want, I know I just recently was discussing with a company called Feel It Technologies from Israel, claim to do this. But I haven't seen the product. I haven't gone in depth, but that is something they can look at, or they can talk to them directly to see whether they have a solution if they have a problem at hand.
Got it. And there's one more question for you, Raunak. So this is about the nature of collaboration between organizations in Industry 4.0. So what is different in the collaboration between companies as it exists today and in Industry 4.0, this extended organization stuff and so on? So how has the mode of collaboration changed because of digital? And if you can give some examples from your customers or the companies you work with, that would be helpful.
So collaboration has existed between organizations, and having extended staff org, extended workforce, extended teams, working through different organizations has existed in the past as well. With digital, it has made it much easier to collaborate and to communicate and to get work done, and it becomes more seamless as if it's one team, right? So what was done earlier in a more, I would say, slightly non-transparent way is now in a much more transparent way that is being done. If you look at it from the IT side, you have a lot of IT service industries, which are almost extended arms of most large, companies. In the same way, in the plants or the manufacturing or industrial side, you have a lot of OT services, which is coming up. OT services is services like IT, but on the operational side, on the plant side of things, right? OT services, I would say somewhere predictive maintenance also would fall under that. You're actually giving a diagnostic service to an industrial plant. And there are a bunch of services which are, it's almost like an extended team, which is there supporting you and, helping you with running your business better. Right? So that is definitely coming up quite well on both IT as well. IT have always existed, right? It's just become better. OT is coming up in a big way now.
And so just a follow-up question, are there startups that are playing in this OT space? In IT, we saw a lot of startups that became big companies. Are you seeing startups in this OT space?
Only startups. Only startups.
Okay, that's good to hear.
Yeah, because the traditional industrial automation guys in the OT are more product driven, right? So we have Rockwells and Honeywells, all this. Yeah, they're typically the large traditional ones. If you see OT services, you see it's mostly startups, digital startups in India.
Yeah, good. So that's one more opportunity for entrepreneurs who want to sort of do something in this industry 4.0 space. They could possibly look at OT as an area where they could, start companies and build businesses.
Yes.
Okay. So Ashok's another question from Ashok. In your opinion, do the IITs teach Industry 4.0 at the BTech levels? Be brutally candid.
So it's been a while, honestly, since so my information could be dated, but from the people who've just joined us recently, it's been quite new to them and the whole process. Industry 4 digitization, I think, as an overview, right, has been broached in few of the mechanical engineering, manufacturing classes, but nothing in depth as such.
Do you wish it was more in depth?
Yes, of course.
It would help organizations like yours.
Yeah, it would. I mean, we are in touch with few professors and few IITs who are getting more in depth with some of this.
Okay. So again, that's, I think, very good input that IITACB can take back to the IITs in terms of refreshing their curriculum.
Mm-hmm.
So I think with that, we've exhausted all the questions. Let me hand it over to Dr. Sushila.
Hi. Yeah. Thank you very much, Raunak. That was a very interesting talk. We when we talk about manufacturing, usually maintenance is not something that is front and center. It is something that usually is thought about at a later point of time. I think today you highlighted for us why it is one of the most important things to think about and build into the design of anything that we do, particularly processes for the manufacturing sector. So thank you very much for that. I think it was very important insight for all of us. You know, we think about core processes. We don't think about what is traditionally thought about as a support process, but it is not really support. It is integral to keeping the industry and keeping manufacturing running. So it is so important. So a few takeaways from today. Raunak started by talking us through the various phases of industrialization, how it has evolved over the last 200 odd years, and then went on to examples of Industry 4.0 and the kind of changes that it has called for. In particular, with respect to maintenance, it became very specific rather than a set of generic statements, which I think is very important for us to really understand what the impact of Industry 4.0 is. We also looked at the impact on talent development and skills, and we looked at skills, we looked at roles, how they are changing, how important workforce development is, how job designs are changing, and we did hear some specific examples during the question answer session, and very importantly, why change management is central to all of this. Companies have leaders who are focused on digital technology and how to integrate it into the business of the company, whatever that business happens to be, whether it is steel or or any of the process industries and so on. Brick and mortar companies that in the past used to have a separate IT department, and I've consulted for a few, so it's very familiar. It was very familiar as you talked about it. Used to be a department that was pushed somewhere into a corner, but today they are really, again, central and very critical to the organization, because using data and big data analytics and so on, not just at a management level, but at every level of the organization, understanding data, integrating it into what people do in their day-to-day jobs has now become extremely important. And we also looked at micro and macro problems, a few examples of that, and how important things like consideration to greenhouse gases and bringing down, and the impact on the environment and so on, are all critical parts of the idea of Industry 4.0. New industries where the application of data science is in core science and engineering areas is required in the industry. So, for example, a metallurgist now needs to understand digital and its application in metallurgy. So it's bringing together these ideas. And then we also looked at some transformations that are taking place in the manufacturing sector. So where 80 to 90% of time of people on the shop floor used to be on activities on the shop floor, it is probably going to now shift to having about 50% on understanding data, understanding what is happening, and the rest of the time would be spent on proactive action, whether that is preventive or reactive or whatever it is, but basically taking decisions and acting on them. India is in expansion mode and currently, and therefore we are not seeing the existing staff being laid off or becoming redundant, but a combination of skilling the existing employees to understand digital and integrating it into all that they do, which of course is not something that's going to happen overnight, together with hiring from new skills, new digital ready skills. So this combination is what is going to shape the way industries move forward. We looked at the importance of rotating assets, which are really at the core of process industries, or maybe all industries. I'm not too sure, Raunak, but the importance of that, and that became a case study for us to understand why predictive maintenance is so important, and therefore the kind of work that Raunak and his company do. And we saw a number of examples of smart machine diagnostics, and some of all of that intelligence is already being built into the machines that are coming out, unlike in the past where these two things had to be done in sort of in parallel, to machines becoming more intelligent, more capable of looking after themselves. And in this context, again, the role of maintenance, so on, will also shift a bit. The importance of things like video analytics, image processing, and not just for equipment and monitoring them, but employees as well. So that's again an interesting case, and many applications, of course, based on big data. So in some ways, we've exploited our world and its resources over the last industry evolution, various phases of evolution from industry 1.0 to 3.0. But hopefully, as we move into industry 4.0, we will become a lot more responsible in terms of making sure that resources are optimized well. We use less resources from the world around us, and therefore industry is going to be good for the world overall. And then towards the end, we talked about the new generation that is joining the workforce. What is it that they want, and therefore what is it that companies need to do to be able to retain them, enthuse them, and keep them productive and going? And Raunak highlighted a few points, one of them being the high level of inquisitiveness, and another one was their need to solve a lot of problems and newer problems, their need for more challenges. So whether it is larger organizations or smaller organizations, this is an area that they're all going to need to focus on in a big way. With the newer organization startups, for example, that are very digital based, they are going to have some of this, much of this already inbuilt. But with traditional organizations, they would need to start thinking about how to bring, for example, a core digital team, and then have that core digital team address problems across the organizations in different areas, so that these kinds of areas, particularly the data science related new age skills, that's where there is going to be a lot of excitement, and people would have many opportunities. Another opportunity for any startup or people who are looking for a career is probably going to be in the area of OT services, that's operational related. And many specialized offerings are coming in a big way and being offered to larger organizations. We are going to see a number of digital startups, probably the next Infosys and so on are going to come from that space. So these was just a few key takeaways from today's session. I just want to say thank you ever so much, Raunak, for doing this webinar. As Narayan also said, this is not an area that we've really given much thought to so far, about how Industry 4.0 is going to call for a different mechanism in terms of the way we manage talent. Today, you opened our eyes to it. We did hear over the last, a lot of what we've done in terms of our webinar series has grown from the industry IIT conclave that we did a couple of years back, just before the pandemic. And we talked about talent. We said why talent is important and why it is critical and key to India's future. But what we did not do at that point of time was really go deep into what specifically needs to be done about it. And you've got us going on that, Raunak. So thank you very much. Samir, thanks a ton for moderating this and bringing all of those good thoughts and questions to the discussion today. And of course, to our audience for being here and for participating, bringing your questions in. The recording of this session, like all of our webinars, is going to be up on our YouTube channel come Monday or so. And we're going to try and do 2 of these sessions every month. So please do look out for the notice and please do participate. With that, once again, thank you very much and goodbye.
Thanks and bye.
Thank you. Bye.
Thank you.